Hello everyone, welcome to Let's Code. So in this video tutorial, we'll be discussing about implementing support vector machines to do prediction on our iris dataset. So as usual, we will be following those 7 steps that we discussed earlier to build a model. So the first one is to load the data. So we actually loading the data from the Scikit-learn library dataset module, okay, from dataset module. So we call it iris, then we load iris data from datasets. And the second step is to get the features and labels from the data. So we put all the features or attributes on X, and then all the classes or labels on Y. Then the second one is to split the data into training and test data. So we call this train test split class in Scikit-learn, and then we pass the necessary arguments, which are X value, Y values, and then what should be the size of the test data. So we want it to be 50% of the overall data, and then random state, which is by default 0. So this will return four variables. The first one is the xtrain value, second one is the xtest value, third one is the ytrain, and the fourth one is the ytest value. So now it's time to standardize the data. So we call standard scalar in Scikit-learn module. So we do fit transform for xtrain and then fit transform for xtest. So now it's time to choose the machine learning algorithm and set the hyperparameters. So it's going to be support vector machine, but in support vector machine, the type of algorithm within the support vector machine to choose are many. We have linear, RBF, polynomial, and sigmoidal. So we will be going through one by one, and then we'll choose the one that gives us better output. So actually I've imported all 4. Then the third and sixth step will be to train the model using the data. Then the 7th step will be to make predictions. So now let's go one by one. The first one is going to be linear. So we have 50% test data, and then we are using all the features in our data. Save this, press F5, execute it. So for SVM kernel as linear, we are getting 94.667 accuracy. So let's close this one. Now let's enable the RBF. So let's make the C value for all same. So I'll go to 10. Press F5 and execute. And for all RBF, we are getting only 29.33% accuracy. This one is going to be polynomial. We change the C value to 10 again. So we are getting 97.33 accuracy. We have only 2 wrong predictions. So this is so far the best. Let's go to the next one. We also make this 10. Press F5. So in this case, we are only getting 57.33 accuracy. So the best one is this one. So we settle for that one. Polynomial. Save. Execute this one more time and ensure that it's the best one. Yes, it is. So yeah. So basically, what we have done here is to explore all the options available in SVM, and we chose right one. So now what we could do is we try to increase or play with these values, which is called hyperparameter tuning, and see whether there is any improvement in the output. It seems it has saturated, so we are not getting any improvement in our percentage accuracy. So let's go back. So and settle for this one, which is 97.33% accuracy. So thanks for watching this video. See you guys in the next video. Bye for now.